Hi, welcome back to DevOps presentation series. This is Satyadev. In the last presentation, we have seen DevOps phases, that is test phase. Now, in this presentation, we are going to see the delivery and deployment. So let's go to the next slide. Now, what is delivery deployment? We have been talking about that about what is delivery, what is deployment, but just let's formalize those what we have talked. Extraction of build artifacts from the artifact server and installation of application onto various test, staging, and production environments can either be done manually or automatically. Right. So when build extraction and installation has to be done manually due to the technical inadequacy or due to the timeline gaps between business need for the build versus actual build generation frequency, or due to the fact that there is a lot of paperwork needs to be done, then such extraction installation phase is called the delivery phase, and in that case, CD stands for continuous delivery. So this is just a what we talked, but here we have given the various possible scenarios where we may have to resort to the manual process, which is the continuous delivery. Now, basically, there are mainly three scenarios where the deployment is automatic, right? So the deployment can't be done automatically because of the inability of the tools or technology inability, or the people aren't available, whatever may be the reason, technical reason. Because of that, we want to go for manual, or that is one reason. And another reason is, let's say business doesn't want it every day. It wants it like maybe monthly once or maybe quarterly once, right? So you don't want to deploy unnecessarily deploy and into test, staging, and production every time you do that. The production anyway we don't do that, but at least test and staging we don't do that every time, right? So in that case, yeah, just in the artifact server, it's good to have the artifacts, the install file or ISO file, or whatever file which can be installed, and then we can manually install. So that is another reason why we want to go for manual deployment. One reason is technical inadequacy, and another is the need for the automatic deployment is not there much. And the third reason is fact that there is going to be a lot of paperwork. There is so much. Sometimes ITL may not be that efficient, IT teams, so they might say, oh no, we want to do a lot of paperwork. It takes time. It's not possible. In that case, also we might go for manual process. Then in that case, we call CD as the continuous delivery, not the deployment. Now, when build extraction and installation can be done automatically, then such extraction and installation phase is called the deployment phase, which is, in that case, CD stands for the continuous deployment, which we have already discussed multiple number of times. Deployment to production has to be done cautiously using the robust deployment strategy. Now, testing and it's okay. There is something bad happens. We can always reconfigure testing machines. But honestly, staging and test and production, they are we have to be very careful because they are more related to the customer. Mostly, all these clients and customers are using it, so it has to be planned very well. So we have to follow a particular deployment strategy. There are several good strategies that are available, but we are going to discuss a couple of them in this presentation. So deployment strategies. Once the application is tested or staging, it is ready for deployment to production. Like I said, there are two possible ways we can do deployment. These are popular ways. There are other ways, but there are two possible ways. One is the blue-green deployment. Another is the candid deployment strategy. What is blue-green deployment? Now, as you know, once the build artifact is ready in the build server, whether it is being done manually or automatically, it doesn't matter. Whether it is the delivery or deployment, doesn't matter. So it is tested on the machine. Once it is tested, it is going to be put onto the staging where specialized users, they test the software in the perspective of the customer. So they test it. Once it is good with staging, the way the blue-green deployment works is, the production machine is stopped for some time. Then whatever staging machine is using, we make the staging machine as the production, and production becomes staging. So we swap the production staging so that the deployment, whenever somebody starts getting onto the server, they use the new deployment machine, which is the staging. right? So basically, that's what it explains. In some situations where maintaining multiple production servers is difficult and expensive, once the application tested on staging machine, the staging machine would be swapped for the production machine and vice versa. So production becomes staging, staging becomes productions. This type of application deployment strategy is called blue-green deployment. Blue is staging, green is production. Blue-green deployment strategy. There is another strategy which is the canary deployment strategy. In situations where maintaining multiple production servers is quite possible, for example, in the cloud environment, it's okay to generate multiple cloud instances at the same time, and it's easy also, just configurable, right? So then in few of those production servers, use your version of the application. So the way it works is, let's say there are 10 servers, production servers that are in the production, right? Now what we do is, and there are users all over these 10 machines. Now we'll pick up one machine, make sure that there are no users, and then we remove that machine from the pool of servers. In that machine, we install the new software and put it back to the production. Now what happens is when new users comes in, if they get to the new server, they get to use the new product. Whereas the other people who are on the other servers use the old version of product. Similarly, they one by one, once everything is okay with the server, all the customers are able to connect the new server fine, everything is going okay, then we will slowly swap the old, take out the server from the pool, install the new software, new version of the software, put it back to the pool. Like that we keep doing it. So that's this is how it's being done. So that's pretty much what is explained. So this is possible when there are multiple servers possible, right? So in few of these production servers, user versions of the newer version of application is installed so that newly logged in users direct to the new versions. However, already logged in users continue to use the old version of the same application, but which is what they are logged into, right? So this is called the canary deployment strategy. So using one of those two strategies, we have to install in the production. So yeah, that's about deployment. Now, about the monitoring and maintenance, I'm not going to talk as of now. It's going to be talked about towards the end of the series. But as of now, let's summarize the actual CD process flow. So this is important to understand because this summarizes whatever you have been learning in the deployment process. So here is the process flow summary, how DevOps automatic CI/CD process in development, build, delivery, deploy, test phases of an agile model framework such as Scrum or Kanban works. Now, the first step is the agile planning. So basically, I have created another presentation series which talks about agile, Scrum, Kanban, where you understand more about these frameworks. But the thing is, in the agile model, there is always something called the planning ceremony. In the planning ceremony, developers, when I say developers, it just doesn't mean the coders. It means the DEV stands for the actual coders, QA, quality assurance team, US, user experience team, documentation experts, release experts, all these guys who actually part of one team, work on the product, right? So all these experts on the planning ceremony, they have this backlog, right? So backlog of items. When they are following Scrum, it is called sprint backlog, and which contains several tasks, which are called stories. When we say agile, when we say Scrum model, tasks is in some other model. You worked on for a fixed duration. So, for example, let's say one team is following Scrum, 2 week Scrum. So, in the beginning of the first day, what happens is there is a ceremony called planning ceremony. In the planning ceremony, there is a list of tasks to be done, which is called the sprint backlog. In the sprint what they do is the developers will pick up those tasks, and the QS also will be assigned. Okay, for this the ABC task, this is the ABC XYZ are developers. K is the QA. Like that, the assignment is done. The second step is multiple devs work on each of those tasks in parallel. Let's say there are 5 tasks and the 5 developers. Each developer will take one task. Let's say there are 10 tasks and 5 developers. 5 developers will take 5 tasks at a time. Then once they are done, they will take another 5 tasks. It's a combination of things, right? So multiple devs work on each of these tasks in parallel. If test-driven development is followed, then each developer would first write the unit test cases that exhaustively covers the task that the dev is working on. Initially, all these tests would fail. Code is written to make all unit tests succeed, and hence the task complete. This is a great way of development. Actually, it is difficult to follow in the beginning, but once it is followed, it is really robust way of development, which is nothing but the test-driven development. What is it? Basically, we know how to write unit tests, right? So I'm going to do a series on that one, but yeah. Unit tests using JUnit or NUnit or PyPUnit, whatever it is, language we are working on, we write unit tests for the code. Now, when we follow the TDD framework, what we do is, let's say a task is to be done. Let's say a web page needs to be created. Now, in the web page, at some location, one component has to be there. Another location, another component has to be there. Something like that we have designed. We want to test the web page, right? We don't develop the page first. We develop the unit tests to check whether in that page that component is there or not. Initially, as there is no code for those components, all those unit tests will fail. Now, the way you write the unit tests such a way that it would exhaustively cover all the entire page, right? So that means if all the unit tests are run, that means yes, the task is done. Now we'll start implementing one by one. So the goal is, make sure that all the tests succeed. Initially, all the tests are there, no code is there. So all tests will fail. Slowly, we'll keep developing each and every task, then all the tests would succeed. Then the task is done. That's how the TDD works, right? So for TDD, that's how they work, right? So they complete the tasks. Once the task is completed, in the third step, while code is being developed a particular task by a dev, it would be periodically checked into the revision control system of the organization, which we discussed already. This process is continued until the task is completed as part of the CA process. This is the third step. Now, as part of fourth step, once the code is code reviewed, automatic or semi-automatic code review process is implemented in the organization, then peers or leads would review the code and provide the feedback if they have any. Like if they think that the code is good, it can be checked in, then they can check in. Normally, this is all done online using tools like GitHub or GitHub has tools. All the version control system, they do provide tools. So using those tools, this process can be automated. Based on the need, they would resubmit the code. If there are any such suggestions given by the peers and technical leads, yes, the developers have to make them and check it back in. And again, code review needs to not check it. Code review needs to happen. Once the task code is approved in review process, it will then be checked into the main branch. So by the dev team. So that will be checked into the dev team. Now the next step would be the check-in would trigger as we discussed, as soon as the code is checked into the main branch, that would trigger build server. So that means a hook is there between the repository server and the build server. As soon as the code is checked in, it will say, okay, there is some code checked in, you need to start the build. The build server, that's what it talks about. The build server picks up the new changes and initiate the build process. In some organization, build process starts at a particular, like I said earlier, it could be a nightly build when there is no traffic. The network traffic means network traffic. The build server builds the particular component that is modified and creates respective binary on the build server and puts the build binary into an artifact server. So basically, it gets the local copy of from the repository version control system and put it locally, and the build server builds it. Initially, you will get the binaries, and the binaries will be compacted into an installer, and installer will be stored into an artifact repository. We already discussed it a couple of times already. Now, one important point I want to mention is that Based on the architecture of the application, it may or may not be necessary to build the entire application. For example, if a microservice architecture is chosen, in microservice architecture, everything is like a small microservice, right? So let's say changes have been done to only one microservice. Then there is no need for building all the other there are 5 microservices. Only one microservice code is affected. So then there's no need for building all the other 4 microservices, right? So yeah, it depends on that. But the entire application has to be built. So use the old versions of use the 4 existing one and the new one, and then create the installer. So based on the need and the architecture of the application, the installer will be generated. So this has to happen, because in order to do the things quickly, even though the code is not changed, if you build it, it's unnecessarily waste of time, right? So in that case, we can avoid it, right? So that's the continuous delivery step. That is as a 5th step. Now the last 6th step is the script are written as part of the configuration system on the build server, notices the new binary and installs it on multiple test environments for running automated regression tests. Again, if as soon as it is kept onto the build server, artifact repository, maybe there is some configuration management running on the build server that, okay, this installer is there, which is put in, then let's put it onto the test machines, right? So in that case, it will, when you implement automatic deployment process, this is how it happens, right? So as soon as the installer is generated, it will be installed onto the test machines, and multiple tests for running the automated regression tests. Regression tests will run. Regression means how compatibility, backward compatibility tests, right? So once automated tests succeed, QA team would run manual tests and you didn't put their stamp on the build. So QA will make, sometimes um, normally 80% of the code can be automated, but at least 10 to 20% code has to be done manually. There are certain scenarios they have to be done manually. In the reality, it's not possible to automate 100%, at least with the way we are setting up these days now. So in that case, they have to manually test a few of the test cases. Once they are done, they will put a stamp. Okay, they will label it. This is what the version that can be used in the staging environment. Once they put a stamp, then the build would deploy to the staging environment. So as I told you earlier, in staging, specialized users, they are actually, they know the product well on, and from the client perspective, customer perspective, they do the end-to-end testing, user accept testings on the staging server by, like I said, specialized users. Once they are happy, then the build will be deployed onto the production server using one of the deployment strategies we discussed a few minutes ago. So this completes the continuous deployment process. In the production environment, automated monitoring tools would continue to run, and any anomalies detected would give rise to the developers. So this is pretty much about the flow of the things in the CA process. Now, the last thing for this unit 1, there are certain challenges that are faced by the deployment, this continuous deployment process. So what are those challenges? Agile DevOps philosophy is that once code is committed, the build deployment process should be done quickly as per the desired timeline. So let's say once the code is checked in, within 1 hour, the build has to be ready for production. Let's say that we put that condition. It's just making up. I'm making up. In that case, all the process should be done very quickly, right? So the build, installation, testing, automated testing, everything has to be done. So in that process, it is done. Now that's not happening. Maybe 1 hour is bit over optimistic. It could be like maybe within 3 hours or 4 hours. So like it has to be have a build, because some tests have to be done manually, right? So then if something is not happening smoothly, then we have to go for a process called Kaizen. Kaizen basically stands for continuous improvement. What does it mean? Like, you see where are the things that are not really working well, and then you improve that process. Now, a deployment in any of the test or staging or production environment may not be deemed to be successful due to several reasons. So you deployed it, but it may not be successful deployment. What could be the reasons? One of the reasons could be, it's deployed, but database schema changes done in the latest versions are not deployed properly. They're not at all deployed. So, for example, you added another column to a table, and you added the code for that. Now, as part of writing your scripts, database scripts, somehow the script didn't go to the production or staging or testing. Then when you run it, it will fail, right? It those exceptions. Even though on the dev machine it works, but on the testing machine and the production machine staging it won't work, right? So then it's a problem. Again, it won't go to, if such kind of problems are there, it won't go to testing at all. Staging at all. It will just stop in the test machine itself. But this is a stopper, right? So that is one of the reasons. The scripts are not properly done. The test data doesn't match exact expectations. So regression tests fails. So, because of the code changes, regression tests could fail. Due to unavailability of skilled technical people, deployment is not. Well, we expect the deployment to happen in 4 hours, but it didn't happen for a day because the guy who is supposed to, do some certain stuff at the, operations guy is not available. He's on leave. That means the knowledge is like, at one place, nobody knows about how to do it. That's not good, right? So that is one way of, when say, it's not a successful thing. It's kind of failure deployment, we can say, right? So it's not deployed properly because the guy who is done it is not properly, doesn't have proper knowledge. Another thing is due to unnecessary red tape. Now, product management team wants it by end of the day. Now, customer support, the IT operations team, which are supposed to enable the operations, they are not available due to some priority, high priority thing. So, and they said, no, we won't do it, we'll do it after 2 days. Then the product customers are going to be affected, clients are going to be affected, right? But again, IT team has got their own label. So this is like a bureaucratic and red tape kind of thing, a lot of process. Now we want this to be done, we want this step to be done. A lot of red tape is going to be there. Again, they want to propagate from one place to another place, all these things. Their process may not be that good. So again, this is one of the things. Again, deployment failure doesn't mean that actual application is bad. It could be it's not meeting the requirement timelines, right? That's also deployment failure. Last but not least is that due to the architectural and other technical inefficiencies, deployment speed is not able to meet this is a very, very important point for the next unit to start. Because let's say we are taking monolithic application, and what we are doing is we are making a small change to the application, very small change to the application. Only one developer is involved. Code review is also not much needed. So the developer fixed the thing, checks in the code, somebody looked at the code, yes, good, there is nothing, only front end change, there is no database change or anything like that. And leadership thing, the product management leadership wants it to be executed by end of the install by the end of the day. No, everything is done, code is checked in, the build server, triggers the code repository triggers the build server start building. Now here is a challenge. Even though the code is small, because this application is a monolithic application, which could take like 8 hours to build. Right, monolithic application could take a lot of time, because even if it is a small change, the entire application has to be built. In that scenario, the architecture of the application is getting inefficient, right? So then it won't happen immediately. It will take some time. Then unit test. Then all the regression tests will be done. Unit tests. It's like several. Unnecessarily, we are getting into this complete testing thing because of the architecture we have chosen for the application. So when we want to go DevOps, in the DevOps mode in the Agile, not only the build process or dev process or the testing process or the automated, but also the architecture of the application is also very, very important. It also has to be in such a way that it should be scaled or it should be tested independently, kind of thing, which we will discuss in the next unit. But this is a good pointer for the next unit. I think that's pretty much about it. And this completes the unit 1 of the DevOps course presentation series. In this presentation, we have started with waterfall model. We have seen the benefits and challenges. Then we went to agile model, how it fixes the waterfall model issues by a shorter intervals of time. But we have also noticed that agile model doesn't address all the issues that could pop up in the code, test, deployment, and monitoring stage. So we need something else. For something else, we have chosen DevOps. So DevOps is basically a combination of development team and ops team. Development team works on the dev part and the coding version control part, but the building the installer and installing it, test servers, staging and develop, that's actually has to be done by the combination of dev as well as the ops team. So we talked about all these things. We talked about the process, the CI/CD process. What are the various phases in CI/CD projects? How DevOps would improve, and we also seen what are the improvements that we can make in dev. What we could make unit tests. Automated unit tests are one thing. TDD, test driven development, code reviews. These are all the automated code reviews. These are all the three things that could improve the development phase. Then we discuss the build process. We're using a centralized repository for servers, which automatically triggers the build. Is for the one step in the build process. Again, build server builds it automatically. Should not build everything. Should be only the component changed, based on the architecture. Then it gives you the artifact server. And from the artifact server, things have to be installed onto the test machines. If succeeded, staging machine. Everything was choose a plan or strategy to get into the production. So that's also could be automated. So these are all the various things. In the coming units, we will discuss each of these things, each of these things more in detail on how we can implement things. We'll see about repositories. We'll see about build servers. We'll see about artifact server. We'll see all these things. And first thing, as we are going to see the architecture, what are the various architectures we can adopt, and which architecture suits best for the DevOps. We are going to discuss in the Unit 2 and so on. Okay, thank you very much for watching this series. This completes the Unit 1. Let's meet you in Unit 2 series. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.